We present a design framework that leverages sketching as an activity to do abstract symbolic mathematics. In this video, we demonstrate an example implementation of the design framework, which is a sketch interface called Neon. In our design framework, sketching visual forms is the primary activity, by which we formulate algebraic expressions. The mapping in the design framework allows us to construct and deconstruct these expressions. We will demonstrate the mapping through an example problem. Let's say there are two neighboring houses, each containing a few apartments. One house is for students and the other is for teachers. What is the total number of population? In traditional symbolic math, we would represent the answer as two variables summed. However, we would need to provide further symbolic expressions to capture all the details. To represent the problem in the sketch interface Neon, we could start by using the iconic elements brush, which lets us create countable objects. Each iconic element created using the brush is assigned a category. Let's denote students by circles and teachers by boxes. Using the copy brush, we can create multiple copies of these iconic elements. We can also use sketching to create unordered lists of iconic elements. Using the list brush, we can create a container that can count iconic elements. Lists have some settable and gettable properties. For example, we can set the name of a list. Using the Move tool, we can move any structure in and out of parent structures. Lists can be drawn in any shape. Iconic elements can also be converted into lists. We call such resulting structures fused representations. Let's erase the existing list and create a list in the shape of a window. We can use the element conversion brush to do so. Lists can contain other lists. We can make some copies of the window list and create a house list named H1. Let's create another house to contain the teachers, and let's name this house H2. We can also create functions using the function brush, which allow us to compose algebraic expressions using the list variables. Let's draw a function container in the form of a street that contains these houses and adds their outputs. Functions can be given a name, and the function operators are changeable from the menu. By default, they add their children's outputs. We now have an embodied mathematical representation. They are hierarchical functions and list structures that also have a meaningful visual description. Each representation is explorable in 3 progressive layers of mathematical abstraction. Hierarchical structures are explorable in the same way. The highest layer of abstraction gives us the symbolic expression h1 plus h2. Finally, to construct and deconstruct algebraic relations, we can use gestures. For example, we can move one house in and out of the street, and that will change the numerical output and algebraic expression. Also, we can use some dynamic illustration tools for storytelling as we formulate these expressions. Let's say we want to create a story that a bird living on the tree does not like too many human beings around. We can define a path for the bird using the path brush and connect the summation to the bird using the graphical transform tool.